The 360 on Energy and Carbon, hosted by 360 Energy. On today's episode, we welcome guest Tony Cupido. As Mohawk College's Research Chair, Sustainable Building Technologies, Tony undertakes leading-edge research that will contribute to a low-carbon economy, while engaging students to develop a multidisciplinary focus on finding real-world solutions to social, economic, and environmental challenges. His research initiatives include the development of an operational performance database for Canada's award-winning, largest institutional, net zero energy and zero carbon building, the Joyce Centre. Currently, he is working on the measurement and validation of innovative air purification and ventilation improvement technologies used in Ontario schools. Tony is on the board of directors for the Canada Green Building Council, representing academia and research across Canada. He is also an adjunct associate professor at McMaster University's Walter G. Booth School of Engineering Practice and Technology. Now let's get into the episode with Tony. Welcome back, Dave.
Thank you, Lysandra. Nice to be back and nice to have our guest, Tony, back as well.
My pleasure being here. Thank you for having me back.
Yeah, and our last episode with Tony was building a zero emission building. This episode, we're talking about operating a zero emission building. So if you're tuning into this one, we do recommend you listen to the previous episode first.
So I'm looking forward to this episode, Tony, because I find when you're building a facility, you're typically dealing with a project manager. When you're operating the facility, you're dealing with a facility manager that have two completely different thought processes. And I'm really looking forward for you to share with our listeners sort of the benefits associated with a zero emission building. So let's get right into it. Can you explain to our listeners what goes into operating a zero emission building based on your experience?
Yeah, Dave, that's a great question. A zero emission building is still a building that needs operation. You still need to do the fundamental things you do with any building, cleaning it properly, doing regular maintenance on it properly, and understanding that it needs attention and needs attention every day. Now, having said that, zero emission buildings, in my experience and what we experienced at Mohawk with the Joyce Centre, there's a lot fewer moving parts. I was amazed, and I had the pleasure of being the head of facilities at Mohawk. I had an integral part into the planning, design, construction, and then the operation of buildings. I kept that in mind so that whenever you're looking at the design of a highly efficient building, a zero emission building in this case, you need to think about the longer term. The construction piece is sometimes as challenging as that is over a period of a year or 2 years or more. You'll be operating it a lot longer than that. And that's really the piece that people often forget, is that you need to live with this building, its occupants, and the operation of it day to day. In a zero emission building, we needed to do a couple things. We needed to make sure that our staff were trained on the components of the building because they were different. But what's important to note is that most of the components of a zero emission building, electrical and mechanical point of view, are very straightforward and actually require little maintenance. And that's a strong piece to me that I learned. Now, what do I mean by that? We have almost 2,000 solar panels for our Joyce Centre that generate enough power to power that building for a period of a year, actually exceeding that on a regular basis, irrespective of the COVID issues, but we're producing quite a bit of power. What is the maintenance in those PV panels? They do not require cleaning. In fact, we were advised not to clean them. They don't require any general maintenance by any of our staff. We did have an inspection program for our PV panels from large electrical firm that is in the business of doing that. They check quarterly to make sure that there's been no disruption in the inverters, wiring, that there's no infestation of birds or other things that can happen. A lot of things happen on our roof that people don't appreciate. And even though we're not quite out in the country or whatever, it's easy for animals to get up there and find some shelter somewhere and make a home and gnaw at wires and other things. So we have somebody checking that. So we check that, check all the electrical pieces, and then check inside in the connections to the main distribution panels. And that's quarterly. And that was, I think at the time we started this, was less than $10,000 a year. It's a simple inspection, double check a few things, and you do that. From a mechanical point of view, where you have heat pumps primarily and a geothermal system, The geothermal system, which is fundamentally the source of our heat for much of the winter coming from the ground and stored heat in there, virtually requires no maintenance. In fact, I spoke specifically to the installer, manufacturer. I said, what do we need to do? He said, just keep an eye on it. If the pressure drops, there might be a leak in there. Chances are that's not going to happen because it's passed all the pressure tests. So the fundamental piece to that is, other than just keeping an eye on it, there's literally no annual maintenance of a geothermal field. Heat pumps require some maintenance, but it's nominal. I often refer to a heat pump unit, and we have 32 heat pump units in our mechanical room. They're like a fridge. They operate like a fridge. They produce cooling and they produce heating, just as a fridge does. When you go to the back of your fridge, it's a little warm there, and that warmth is drawn down and put into the ground for use in the winter. But how often do you have to maintain a fridge, other than checking some things and making sure that it sounds okay and it doesn't get abused, don't leave the doors open and all those types of things? The general maintenance of that is nominal. And that's the same for a geo-exchange system like that. Now, we do have one major air handler, which is fundamentally not much different than most air handlers. It does have a heat recovery wheel. It does have pre-filters and filters, and it does have some systems in there, and they require a regular monthly. Filters typically, depending on the location, should be changed at least seasonally, and you have to make sure you're on that. We also had to upgrade to MERV 13 filters, like many places did over the last couple of years. But that, along with the water reclaim system for rainwater harvesting, which goes through toilet use, which maybe has the most maintenance. You just have to check some filters and the UV protection that's provided in there very cost effectively. We're seeing the annual operating cost to be easily about a half of what it typically would be in a building. And again, we've only been in really three full years of operation. We're just trying to understand and analyze things. We had to go through a warranty period, which helped maybe pick up a couple of quirky things. But generally, the ongoing maintenance of a zero emission building is much less. I would say conservatively at least half of what it normally costs, and could be less. Now, you have to clean it. Whether it's that building or not, you have to do all those fundamental things. You have to do some things in there. But generally, utility costs are low because it's all LED lighting typically. And maintenance of LED lighting, and that replacement of LED lighting is, I don't even know of all the stats. So at home, when you buy a light and it says 20,000 hours or more, that's a long time. So often you don't have to worry about all those. And we, other than the odd fixture that seem to go out, and that can happen when you have thousands of fixtures in there, the costs are low. And I would encourage anybody to make sure you consider that in your costing of a building from a long-term perspective.
So you've answered some of the questions I have, but I'm going to summarize this. Certainly the operating costs, as you discussed in the previous podcast, typically less consumption because the building's built better. But you're also just described that the maintenance cost can be half of what a typical building is, which has got to be an attractive feature for the private industry to look at as well. So it seems, Tony, that there's like a triple win on this thing. Your clients like it. Capital costs look almost the same if you do it right. Operating costs is significantly lower. Maintenance costs. So, okay, what are we missing? Like, what is it that people don't know the issue or challenge with a zero emission building? Is there something that that they should be aware of, that they need to be mindful on this operating?
Yeah, no, that's a good question, Dave. I mean, there are still some different pieces of equipment that are typically in here. Often it's heat pump type systems, variable refrigerant flow systems, so they can heat and cool. There's air heat pumps with air absorption that often in the residential piece, but often put into many buildings. There's different types of equipment that require different layers of inspection and ongoing maintenance. And every indication is that zero emission buildings do perform easier from a maintenance perspective because there's less moving parts and the systems are better than some conventional systems. What I may be getting at is, it's an interesting analogy quickly. I went to a new building at the University of Western 2 years ago, a new engineering facility. It's gorgeous. Uh, it was a LEED Platinum building. They couldn't get net zero at the time, which is timing and the issue related to the design and grants and everything else. But when you toured the facility, it was an excellent facility on their campus, but their mechanical room was very conventional. It had boilers, chillers, uh, numbers of pumps and systems in there that were just based on the amount of infrastructure within that mechanical penthouse, just demanded more and more maintenance than you would typically ever experience in a zero emission building. And that's what I stress to people, is that the operating costs, I think, are in line with the simplicity of how these systems operate. As I mentioned, there's very little to do with heat pumps and geofields. We only have one air handler for 100,000 square feet. This building at Western in London had 3 major air handlers. That's 3 times the filter. It had the same size building with the same, exactly almost down to the square foot, same size, just a different configuration. It ran efficiently, but not nearly the way you would think. If you have 3 times of anything, including a lot more space and equipment that goes with all that, there's a cost associated with it. So we would encourage anyone to think about the simplicity and understand that the maintenance costs are synonymous with that. You have simplicity in your systems, you'll have simplicity in your maintenance typically as well.
So, Tony, just to follow up, and this is again a surprise to you and probably Sandra, but the thought I was wondering, because of the equipment you're using, is it a challenge, or how difficult is it to find service providers that can actually help maintain that? Is that readily available, or is that difficult to find?
That's a great question, Dave. And I would say, first of all, just because of the nature and the size of our complex at Mohawk, we do have in-house staff who maintain systems. But the systems here in this particular building are very straightforward. I'm going to start at the very basement and work my way up to the top mechanical room. We have a water treatment system for the rainwater harvesting. It's different, but it's not complex. It takes a couple filter changes on a regular basis. And usually there's an indicator that helps you know when that takes place, but it's usually every 6 months. There's a UV protection there that has an indicator light when the UV bulb needs to be either the framework has to be clean, which is often step number 1, or the bulb has to be replaced. And so extra training was involved, because you don't have those systems anywhere else. But that's pretty well the nature of it. There is a computer system that just needs to be double checked. But other than that, it's minimal. As you move up through the building, we have package units in each area that help with controlling the cooling and heating within each individual space. And those require very little maintenance as well. They do have some drains in there that need to be double checked, not unlike any other facility, but every indication is, after now almost 3 years, that there's been virtually no maintenance associated with those. As you move up through the building and into the mechanical room, we do have a service contract for the heat pump systems. Our own technicians, although they're trained on observing and maybe understanding how they work, the maintenance of those is something that typically is outsourced. And to my knowledge, in the last 2 years, there's only been a handful of calls for something that may not have been working properly or didn't sound proper. And that's nominal, as opposed to often when you have boilers, chillers, cooling towers, and other things, they're just regular things that need to be done and checked and replaced on an ongoing basis and tested. That is not the case in this particular building. As I mentioned, in the geothermal field, which is now back and down on the ground, there's no. I talked to the installers. You don't need any maintenance on these. It's designed not to be maintained, observed but not maintained, because you don't touch it. It's buried in the ground. And I think where some early detractors of these geothermal systems were from 5, 10, 15 years ago, some early adopters found that some of the installers and some of the technology and the equipment used was a little bit early day, and that's been proven out now, and there's much better quality. So what I would say is you need some. I would recommend on any larger building that you do have some staff who are properly trained to understand and observe and do some of the fundamental things. But otherwise, you outsource where you need to, or have a service contract, which is probably the most economical, and sometimes it's only used on an as-needed basis we're seeing it's not needed very often.
So obviously it would be easier to efficiently operate any building if they remained empty. However, that's unrealistic. How much impact can the occupants have on a zero emissions building?
Yeah, that's a great question. And one of the things that one of the largest energy draws in a zero emission building is often the what we call the equipment load or plug load of the building. So in our case, if it's fully occupied, you have 800 students and staff plugging stuff in to accommodate their use of that building can be a major draw. That's anything from equipment in the classrooms and the labs to people plugging in laptops, cell phones, and other things. What we did there consciously is, first of all, we're metering and sub-metering over 40 points within the building. So we understand we're metering all the plug loads, we're metering the lighting load, we're metering even the elevator load, we're metering different rooms and the loads that come from there. So we understand on an incremental basis where our biggest draw is. And what we have stressed, and what we did stress in the design, is not to put as many available plugs as you would normally see in a conventional building. And we advise students of that, saying, look, there is the ability to plug some things, but when you come in here, you have to think about being prudent about your use. Just don't come in here and automatically plug in your phone, although if you do need that, we have that ability. Or your laptop, work off your battery. Like think in the mode of an environmental occupant, and that's gone over well. Yes, in our digital creativity center, which is often referred to as the old library in older terms, there is the ability to do some of that plug-in, but most students now are learning to work in the mode that it was intended to. And we did that through some occupant information sessions. We had peer sessions with fellow students who understood the building and working with other students on the ability to help them convert their regular thinking. So that's important to do. And what we found, we were successful at doing that. People were adapting to it. We now have the data and demographics. So I would recommend to anybody thinking about this, understand your data and demographics of how the building operates, and then you can fine tune this. So once you have all that information, we're still aggressively fine tuning as much of the operation as we can. We can always still cut back maybe on our lighting if we don't have a lot of occupancy, because even in a very low occupied building, even a security guard walking through the corridor will trigger the sensors to kick on the light, to kick on the heating, and all these types of things. So part of it is a bit of an operational piece where you try and make better efficiency of how that works. But the last thing we wanted is, and sometimes you see this in office towers in Toronto, just simply because you have staff, cleaning or maintenance staff working at different hours, you see the whole building lit up and there's hardly anybody working there. There's these sensors that need to align. So there's always work that needs to be done. We're doing research on that. We're doing operational metrics on it, see how we can work that out. But we're operating right now at almost about 60% of our design targets for energy. I know it's not fully occupied, but there is still some occupancy in there. And we're still trying to refine that. But once students are back in and we have a full operating metric there, they'll give us a better understanding of it, not just in a time of basically a shutdown that we are experiencing right now.
Tony, you've outlined the advantages to building and operating a zero-emission building in both of these episodes. For our listeners and those considering zero-emission buildings, what are some challenges that are associated with them?
Yeah, that's a great question, and there are challenges. There's no question about it. Building is still a building, and there's things that need attention all the time. I reiterated that some of the mechanical, electrical systems are better systems in terms of the need for a lot of oversight and maintenance, but there's still computer systems that manage these. There is some difference in the convention of how these systems, when we first had this building commissioned, and I would highly recommend that anyone commission their building, not just take it over from the contract, but have a third party come in and kick the tires and make sure it's working the way it should. There were setups that weren't appropriate. So the challenges are still similar to what you have for opening any building. Making sure that your building automation systems are aligning properly, your sequences and your schedules are all working the way they should. And in some cases, we discovered that simple things like supply and return, which are conventional terms of where flow goes within the building, are a little different in a geo-exchange system. Supply in this case isn't supply to the building, it's supply to the geothermal field outside. So we had a technician who didn't quite understand all that in early days, programming things to stop and start when they should have been opposite because they were supply and return. We discovered all that. We have a solar thermal system to provide hot water for domestic use in our building. We were studying that when it first opened up. We had students doing a little bit of research project, and they were determining that there were some odd metrics in how the graphs were coming. It was a hot sunny day and the temperatures weren't going the way they should, and other things. And what we discovered was the piping coming through the floor slab side. You have solar thermal panels outside, and you have two pipes, supply and return, coming into the building and up through a floor slab to connect it to the equipment that's there. We found that the installer of the equipment inside our building actually got the pipes crossed. So we had supply and crossed. They were inverted. Now, it didn't mean that they weren't working really, but there was you weren't getting the performance at all that you should have. So the point being that there's still simple things that happen. Even with all the design and simplicity of technology, somebody made an error in how they were installing some equipment. And even with cross checks, sometimes you don't pick that up. So we had to get the supplier back, and I was there going through some different things. And we finally determined that after half a day of analysis. So there's things that you have to think about. There's some different equipment, which requires a little bit of different thinking and some maintenance. There's also the point that the occupants will maybe not understand how this system works. The occupants still want comfort, but there are some things that are a little different, and you don't see peaks and valleys in the performance. In a building, if somebody's too hot, you can turn heat down right away. If they're not cool enough in the summer, you could, quote, pump up the air conditioning and get that going. Zero emission buildings don't work that way. They perform generally over the same period of time in a very narrow band of temperature. There isn't these ups and downs that you normally see in a conventional building. So even though there's hot days, and we have had lots of those, and some cold ones, we've had plenty of those too, the temperature and the performance of the system is very gradual. And you set it at a certain temperature and it behaves that way over just like your fridge does. I'm like most people, with the rare exception, I've never touched the thermostat in a fridge. Some people have. There are occasions when that's the case. Sometimes an older one, it freezes, and they sometimes turn some things. But just like that, you just don't adjust anything in these types of systems. It's very casual and very nominal, and which is different than a conventional system, which you wake up, building manager says, hey, it's going to be really, really hot, humid today. We better crank up the air conditioning. That isn't the case for these types of buildings. So the operation is subtle and different. Occupants may not recognize it. And that translates into some good performance metrics because you're not doing a lot of different things on a regular basis to the building. It almost operates at the same temperature all year, which is a good thing. One of the challenges, and it just hit me as I got through this, is sub-metering your building to understand the energy performance across the building. And the sub-metering world is still developing, in my opinion. It's still relatively new. It's getting better. But I know I gave a talk a few years ago in Oakland at a net zero conference, and I talked about some of the struggles we had with metering and sub-metering and how those meters worked, related information, some of the data that we were coming across. And there were lots of variables in there. By the nature that you buy a meter, it could be not the metering company who installs a meter, it could be an electrician who's a specialty sub to the main electrician, and you don't get all these moving parts working together to read properly. I know when we had some problems with our sub metering, we called a meeting up to the sub company, and it was amazing. We had a room full of people. One was the supplier of the product, one was the software manufacturer that went with the product, one was the installer, one was the general electrician, there was the general contractor, then there was a local distributor of the product and everything else. So in a particular world where it's very critical to maintain and understand your consumption in that particular building, we typically hadn't, we as certainly in the institutional world, and maybe even in the private sector world, weren't overly concerned about metering. Either the private sector was off to third parties, tenants were paying their metering, and that was one thing. But for us, I remember putting up buildings at McMaster where we didn't even put a meter in the building because we had a central meter plant in our power plant. We didn't worry about what building X consumed. It was all part of a bigger piece here. Now you want to know that metric, and the way to do it is obviously a building meter, which we have in our homes and other places, which pretty standard, well tested. They're what they're called revenue graded or revenue rated meters. So there's lots of technicality that goes with that. But in a building, it's a little different world. There's lots of pretenders out there who think they have the right sub-metering systems. And we found that in the US, a lot of people were saying the same thing. That was still something that's emerging that needs to be a lot better. So that is one issue. A challenge for operating these buildings is understanding the energy consumption metrics in specialized areas.
I think, Tony, it's a really important point. I mean, this is in our podcast in the early days, we were talking about how data is so critical. You need to have the appropriate data to determine where you are and where you need to go. And you've just illustrated how critical that is in these net zero buildings. So thank you for sharing that for sure.
No, my pleasure.
Thank you again for your time today, Tony. To conclude this episode on operating a zero emission building, what is the biggest takeaway?
Yeah, that's another great question about operating a building. What needs to be taken away by individuals that need to understand this? I think there's a couple of things. There's some pros and cons. I'll leave it that way. Pros are that there's a lot fewer moving parts for the most part in operating these buildings. So other than some good old-fashioned maintenance schedules and understanding what needs to be done at certain times, I would not hesitate to say that there will be much less day-to-day, month-to-month rigor that's needed to operate the building as opposed to a conventional building. So that's a good thing. And there's fewer larger pieces of equipment. So again, in this one particular building I'm referring to, the JCPI, we only had one major air handler. Where it was a conventional building, we would have had at least three. That's 1/3 the number of filters and gauges and coils and other things that have to be checked. So that's an important piece. So that's a pro. Another pro is that if you have good trained staff, it takes fewer staff to look at all these systems and maintain them. They can be focused in on some more of the conventional equipment that you have in other buildings or other settings within your building portfolio. The cons are this. It's still new. We're still learning a lot about this equipment, whether it's something that is simple, in our opinion, like a solar thermal system that produces hot water. You can run into quirky circumstances because of the installation. So, a con is that it's new. You've got to learn a little bit and probably introduce new maintenance contracts and technicians that will come to your building that you don't have anywhere else. If you have a rooftop unit and you have a service technician, that technician can probably do all the 1 million square feet that you have on your campus because there's lots of other rooftop units. But in early days, you only have one heat pump system. You only have one geothermal field. It takes a little bit of specialty and to get used to that and understand it. Another con is kind of relating to the ability to check the systems. As I mentioned about metering and sub-metering, you need to really understand what your building automation system and what the information it's providing for you, that it's a little different. The conventions can be a little different. The set points can be a little different. And you need to have a better understanding. As experience happens, you'll understand that it takes a little bit of subtle approaches to operating the building differently, and you can expect different things. The other thing, the biggest takeaway is anytime you're operating this building, and I refer to when we were constructing the building, but operating the building, you have to look at the building operation over a period of a year. At any moment in time, you'll have certain things that are happening, but the system is really something that you need to appreciate over a period of a year, because it will be the data points and the graphs and the outcomes that you see over longer periods of time and through 4 seasons that will help you better understand how this building performs. And as I mentioned, there's some very conventional things, like if you look at the solar panel PV output. You can imagine it's great in the summer and it tails off in the fall. And it's really low right about now in February, and then starts to peak up again. Well, there's other components as well you have to look at in terms of how the building performs, and some of it fits the models and some of it doesn't. So you need to have a little different perspective of how you interpret the data. So that's a takeaway, that it is different building, but as you get more comfortable with it, operators and managers can start to appreciate that the systems do operate more easily and much fewer swings in the way the building systems come on and off and things like that. So the takeaway is the operation of a zero emissions building can be simpler, and in a broad context can be simpler than a lot of conventional technology that you see out there.
Thanks for that, Tony. Dave, any final comments?
I think the last two podcasts with Tony has showed me or confirmed that energy is controllable, because when you're building a net zero building, you have to take that into account. It requires the integration of not only capital costs, but operating. You have to look at life cycle costing. And the last thing, which I think a lot of people don't interpret or understand, is the human behavior. It's really important to have people involved, not only in developing the building, but understand who's going to be in the building going forward, what their needs are, and how they have to play a role to maintain. So you actually are not taking energy for granted. So you're actually heavily involved in the whole process. So it's a great example of how energy is controllable. And Tony, thanks for sharing your information with us.
No, my pleasure. I'm always happy to share about our experience with buildings. And I think a lot of my colleagues are moving in this direction. The marketplace is moving in this direction. So the more information we can share amongst building managers and owners helps the industry. And we're here to do that. And we're teaching our young students to be the young individuals who will help with the design and be the technicians of the future to maintain these systems. And there will be a lot more of this as time goes on.
What did you pick up, Lysandra?
Yeah, I think operating a zero emission building opens up a lot of opportunities. And I think when we think of the transition of a conventional building to a zero emission building, there's going to be less people maintaining, let's say, oil and gas systems. But I think it'll open jobs in different areas, such as building PV systems or geothermal systems, or even maybe courses just dedicated to operating a zero emission building, that it then becomes that person's career. So when we get these guests on and we get to learn about these new opportunities, it's very interesting to see that there's going to be a huge shift in job culture in the next 10 years. And I think, yes, certain jobs may be going away, but I think in the same way, there will be new opportunities in the same areas.
It's really exciting.
One thing I think you'll be seeing too in the future, and I just had a discussion with a colleague a couple months ago out west who is studying artificial intelligence and its role in building management. And we'll see much more of that. We have systems now called building automation systems that help us with day-to-day activities and just keeping an eye on some things and also flagging us for some alarms and problems. Many of those typically are avoided or ignored during a common day. But artificial intelligence will actually start to take steps to resolve some particular issues within a building on its own. It's going to take a lot of work to do that, just as we're seeing with cars that have their autopilot, that, it can do a lot of great things. But, a squirrel jumps out in front of the car, they just don't understand what to do. The car just doesn't quite know what to do. And you can't just slam on the brakes because you're going to go through the windshield. Same thing, it's going to take artificial intelligence to help recognize some of these systems and know when to make changes and subtle changes and know when to dispatch a technician perhaps to look at a particular problem that can't be solved remotely. But that's the coming world, a much better oversight of building maintenance through artificial intelligence.
Great point, Tony. Well, thank you both for your time today.
Yeah, thank you, everyone. Thanks for the invite. I appreciate it.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn post. See you next week.